everyone. Good morning. I hope you are doing well. I was waiting for more participants. I'm a little bit sick. Sorry about my voice. But let's start because I think you have also other things to go on in the next hour. So I think we can start. So thank you very much really for participating to our Young Research Seminar. So we are really happy to have you in this session. So today we will have three presenters. Dr. Bilge Yilmaz from CA2 in Turkey, Hilal Fazli, Dr. Hilal Fazli from CA2 again, and from Kamperidou, Vasiliki from, is he here by the way?
Yes, hello. How are you? Good morning.
Good morning. How are you?
I'm very nice. Thank you. Thank you.
Thank you. So, yeah, you're here. Sorry, I didn't see you. Yeah, because I saw Hilal and Bilge. Yeah, you are here. Thank you very much. Your surname is Vasiliki, right?
No. Kamperidou is the surname, and
Ah,
Vasiliki, you can
okay.
call me Vasiliki.
Okay. Thank you very much. So she's going to, Dr. Vasiliki is going to present also a research about chemistry and wood improvement from Aristotle, University of Thessaloniki. So you can start, but I don't know, like, how did you decide? Maybe Bilge will start first? Okay.
Yes, I can start. Thank you, Dr. Eda. Also, I want to thank you all the all organizing committee to introduce ourselves and universities and all research. I open my. Okay, I don't have I think opportunity to open my. Please.
You can't share your screen?
Yes, I can't share it now.
Maybe you send it in the chat and then maybe Satem
Okay,
will help us.
I can add it. How can I send?
You can go to chat and I think you should be able to attach a document, no?
Oh, I don't see that.
Chat, it's below. Do you see there is chat?
I see, but
click on there and then there's a file option.
File option.
Like click to the chat. Did you click to the chat?
Yes.
Okay, do you see type message here in the chat box? Click on the chat.
I click, but
okay, and then do you see type message here? And then there is a sign below that. Do you see the smiling face?
Yes.
Next to that, there is file.
No, I didn't see the file.
No. Do you see the smiling face?
Smiling
in the
face?
chat box?
In the next?
There is a sign like square.
Okay.
Did you see the file button now?
Yes.
Okay, so you attach it there, I think then, and make sure you send it to everyone, and then Satem wrote us something. Any problems? Yeah, she's not able to share her screen, so she will send us the file. Did you do that, or just send an email maybe?
Yes, I can send to.
Maybe in the meantime, Vasiliki can start.
Yes, maybe.
And you send us an email.
Yes, I can send now.
Okay, just send me email or to Taner.
Okay.
Vasiliki, will you be able to start? Okay, Setem wrote that I just made her co-host. Now you should be able to share screen maybe. Anyway, let's don't waste time. You send us email, and in the meantime, maybe Hilal and Vasiliki can start.
Okay, I will now I am sending you an email
Okay.
because I don't see any things, because just sharing the sharing the screen, not give me permission to send the presentation. I don't know why, but I will now I am sending you
Okay.
presentation.
Vasiliki, are you here? Or Hilal?
I sent you now.
You send me? Okay.
Mm-hmm.
Did you send to my email? Because I didn't receive it yet.
Yes.
Okay, now I got it.
Mm-hmm. You see?
Yeah, I have it. I will download it and then I will send it to the chat box. And then I think Satam person should be able to share it.
Bilge, I think you are now the co-host. So can you try again?
Okay.
Bilge, is there a problem with
Because I am no, the before I don't have a.
Taner, can you share screen by the way?
Yeah, I can.
Okay, I forward the Bilge
Also
presentation
now
to you.
I can share. I have a I can I think Taner give me permission.
So okay, you
Okay,
can start
then
it.
if it works, yeah, you can start.
Yes, I am now now I am sharing. Sorry. You see my screen?
Yes, it says has started screen sharing. Yes, very good. Yes, and if you want, you can make it the bigger screen. If you go below, yeah, go down.
Okay.
If you do Control L, I think
Okay,
it
okay.
should also work. Yeah, exactly. Or you
Sorry,
press.
sorry.
Yes, very good.
Okay.
Yes, thank you
Thank
very
you.
much. Yeah,
Thank
yes.
you. Thank you again for the organizing committee to introduce ourselves on our universities and thus research or research. I want to tell about some information about bio-based resin, especially on natural resins, pine and others. I will show you what I am want to mention about. So firstly, I want to introduce my city. My university is in the northeast of Turkey. This city is very popular for the natural beauties and historical places, mainly Sümele Monastery is very, very important for the Christian people. Every year, much more people can come and go and see these places. Also, there are much more places to natural. They have a natural beauties. For example, Uzungöl, and very much more highlight the highlighted areas. People can climb and people do some sports in their areas, and in the middle photos you can see it is in our university area. It is near the sea. and near the airport. It is the first. It is the one of the university is very very near the airport. It is very easily arrivable and come after airport to university, just 5.2 minutes by walk. And I have a small video about our university introductory video. It is 4 minutes, but I can, if I have a chance, I can high the speed for the easily not to be bored. You. Also, yes, I go back my slide. Yes, my study area, especially on natural resin. But you want to learn about the what is the resin? The resin that I am working on is composed of 3 different resins. One is the from living pine trees. The other is the extraction from pine stumps. The last one is the using the sulfate pulp metals, sulfate resins. We can use 3 different natural resins. Two of them from waste, because we use the stumps, and the other sulfate resin we use black liquor from the cellulose production. And only one the living pine trees is a product from trees, especially pine trees. Pinus glutea, Pinus maritima, especially is using for the production of the resins in Turkey. We will look at the wall universe, for example. What is the worldwide production and trade of the resin? The 90% of the resin production comes from, as you know, China, Brazil, and Indonesia. The global fine chemical market is valued at $5 billion, and it is experiencing the continuous growth trend. Among continents, Asia has the fastest growing market when we talk about the resin market. So, what is how is the situation in Turkey? Turkey can produce resins, but very much low tones. But we have totally approximately 80,000 tons crude resin sourced from the trees. But unfortunately, 2021 we produced nearly 250 tons, very little. But we have a opportunity to much more produce, but unfortunately it's very lower. And if we want to talk about the sulfate resin, one company in Turkey, Oyka, can produce annually between 1,500 to 1,800 tons per year tall oil. Wood extraction resins also one company we have in the Balıkesir city. Nearly 500 tons annually they can produce wood extraction resins. So when we look at the global outlook, as you see the graph, it is very important, I think, because in the 2029, the pine-derived chemicals can up to, it is estimated, it can up to $7.5 million. It's very big, because resin is a very sustainable bio-based chemicals, and you can easily convert it very different properties biopolymers, because it is very popular these days. Up from the past it is using, but nowadays it is very popular for the sustainable and biodegradable properties. And in our lab, firstly, we start to produce rosin from resin, because we use rosin. Rosin is the solid part of the resins, natural resins. It is the instrumental setup in our lab. We started with these. First, we produce rosins from fine resins. Rosin is a solid part of the resin. We use this solid part to change the chemical properties and produce different biopolymers from the material industry. I want to tell about some information about chemistry of the rosin. Chemistry of the rosin comprises of two different resin acids. One is the pimaric acid, the other is the abietic acid. Abietic acid is the most abundant in the rosin. The other resinic acid you see in the slide, these are the resinic acids, is the isomers of the two resin acids, abietic and pimaric acid. The main important resinic acid, abietic acid and the pimaric. The others isomeric resinic acid from them. So you see the abietic acid chemical structure. You see the free carboxylic acid. We use this structure to play and change the structure and produce different materials. You see these types of reactions we can play on that. Pimaric type resinic acid on abietic type resinic acid. These are the aldehyde reactions, reduction reactions, oxidation reactions, esterification, salt formation. These are all reactions can easily conduct on the rosin to make different materials. In our lab, we can produce rosin esters, especially on penteritol esters. We use penteritol and abietic acid and the very high centigrade degrees in an inert atmosphere, and using various catalysts, we can produce these structures, for example. And these esters using especially on the thermoplastic road markings and surface coating, paper industry, adhesives, and other applications you can easily using. And we have some papers about thermoplastic road markings. We succeeded, and we have 2 papers about that. Also, you can see the instrumental setup of the esterification reactions. Also, we use inert atmosphere, and we use mechanic treater, because the rosin is very viscous in the reactions. And the other is the isoamyl ester rosin. We use the isoamyl alcohol from fusel oil. Fusel oil is the waste from the sugar cane companies, and we use this fusel oil and fractionate it in to the isoamyl alcohol, and we also ester with this alcohol, and we use this medium density fiberboard production. And we have a paper on that also. You can check. We also we apply to patent for these chemicals, because the results show that the isoamyl ester rosin can be adaptable to paraffin in the medium density fiberboard production, because you know the paraffin is the hydrophobic and petrochemical product, but isoamyl ester rosin bio-based, sustainable, and also we can use the waste to product, because on that we apply to patent, and it is also ongoing on the application. And these are the photos on the to production of the isoamyl alcohol and fractionation setup you see. Also, these products from TÜBİTAK project, individual entrepreneurship program, we also applied for the grant. And we have a silver medal in the Technofest for this project, isoamyl ester rosin project. This is the experimental chemical structure reactions you see. Firstly, we converted abietic acid to levofumaric acid, and then we esterified levofumaric acid with isoamyl alcohol and some ingredients. PTCA or organoxantan, they are the antioxidants and the catalyzer of the reaction. And we also produce isoamyl ester rosin to use not only for the MDF, but also in the epoxy resin system as a curing agent, 2 different directions. And you see these experimental photos. We successfully produced epoxy resin systems, and also we published this research. Very much different areas you can adapt of this polymer. And our last research about on the production of the rosin-based antibacterial nanofibers for particulate matter removal. We conducted this research in Italy, Politecnico della Marca University, via bilateral research, and we successfully adapted or modified rosin in the electrospin systems and to produce the filters, and we did some antimicrobial tests, also particulate removal test. It is very nice results we have it. Also, we published this research. So thank you very much for listening to me. If you have any questions, you can write me in email. Thank you very much.
Thank you very much, Bilge. It's really interesting. By the way, my brother is also a graduate of CA2, but years before, so I'm sure it has changed a lot since then because he studied in the 90s. So I'm sure the campus has grown a lot. So it looks really nice, the video that you showed us. I have never been to Trabzon actually, so maybe next time.
Welcome to Eda every time. you can.
Thank you very much. Yeah, my brother studied there, so that's why I remember. I was a child back then, of course. But yeah, he used to tell me a lot about the city. Yeah, the next Hilal will start, I think. Now you can share your screen, Hilal. Does it work?
Yes, can you hear my voice?
Yes, yes, we can hear you. Yes.
Ah, super. Vasiliki, hi, everyone. I had a problem first, my camera and my voice, but it's okay now.
Yeah, you wrote us, and we saw it, yes.
Yeah.
Good. Yeah, these technical things always happen.
Okay. I didn't open because you have to allow me to share screen.
Okay, let me write to. Do you hear us? Someone from SETA is helping us. Let me write.
I try. No.
Yeah, now Hilal Fazli is the co-host now. I think it should work now.
Okay. Okay. Open.
Maybe.
Yes, it's okay.
Yeah.
Maybe
Yeah.
now. Can you see my screen? No?
Not yet. Now it's coming.
Okay, maybe we will wait
Because it's saying,
because our PC very slow
so
work.
it said has started sharing. I think it's coming. Yes.
Okay.
Yes, now it's here.
Okay.
Yes, very good. Now we see it.
Okay. Super. I started.
Sure.
Okay. Again, hello, everyone. First of all, I would like to thank you for giving me the opportunity to introduce myself here. My name is Hilal Fazli, and I am a PhD student in inorganic chemistry at Karadeniz Technical University, saying hi from Turkey. I am planning to complete my doctorate in May 2027. In my research, I synthesize metal phthalocyanine macromolecules containing various bulky substituent groups, and then we evaluate their activities in a different application field. Next one. The green and blue colors you see here are specific to the phthalocyanine macromolecules we have synthesized. Thanks to these characteristic blue and green colors, phthalocyanins are widely used as color pigments in the dye industry. Phthalocyanins are aromatic molecules with excellent chemical and thermal stability. The molecule you see here represents a phthalocyanin molecule with metal. And due to their excellent thermal and chemical stability, phthalocyanins have attracted research interest not only in the dye industry, but also in many other fields. For instance, they have been used in areas such as chemical sensors, catalyzers, optical data storage, electrochromic devices, liquid crystals, nonlinear optics, solar cells, even and energy storage applications. And so how are these phthalocyanine molecules synthesized? Phthalocyanine exists in two different methods, forms, metals and non-metals, as known as non-metals free phthalocyanins. As you can see, metal phthalocyanins can be synthesized using three different methods, while non-metals ones can be synthesized using 4 different methods. And how do they determine whether the metal ion has coordinating to the central cavity of the phthalocyanine molecule? Of course, UV visible spectroscopic technique. The UV absorption spectra of metal and non-metal phthalocyanine molecules are shown here in the figure. Non-metal phthalocyanine exhibit a split Q bond appearing as a double peak. Double peak, blue line represent this molecule without metal. However, when a metal atom occupies the central cavity, the phthalocyanins show a single Q bond. This is a red line represent these molecules with metal. In this way, we can determine whether the metal has successfully coordinated to the synthesized phthalocyanine molecule using the UV visible spectroscopic technique. And since phthalocyanine molecules have a planar structure, so they tend to stack on top of each other due to the PP interactions. PP interactions at this situation is a disadvantage for its applications area. This stacking prevents their solution in water or other common solvents. This situation known as aggregation. Aggregation in turn limits the practical application of phthalocyanins. To prevent aggregation, bulky substituent group can be attacked to the peripheral, is here, non-peripheral, this blue, white, and or axial position. Yes, this is axial positions of the phthalocyanine molecules as shown here. This hinders the molecule from stacking and makes them suitable for use in a wide range of applications. For example, in photodynamic therapy, PDT, it is crucial that phthalocyanine-based catalysts designed to kill cancer cells are soluble in biocompatible solvents such as water. Here, I will give you a few examples related to the literature studies we have conducted. So, for example, in this study, we focus on the oxidation of benzyl alcohol, an abundant compound in nature, into benzaldehyde. Benzaldehyde is widely used in medicine and even cosmetic industry, making this a sustainable research topic. It has been determined that the water-soluble metal phthalocyanine molecules we synthesize exhibit a remarkably high potential for converting benzyl alcohol to benzaldehyde in solution. In conclusion, we have developed a catalyst that enable the oxidation of benzyl alcohol, typically considered a waste material, into benzaldehyde, a valuable compound. And next one, to evaluate the potential of the newly synthesized water-soluble metal phthalocyanine compound in Alzheimer's disease, their in vitro and in silico inhibitory activities and cytotoxic effect were investigated. It was determined that the synthesized molecule exhibit high cytotoxicity effect. In this study, a silicon disubstitute phthalocyanine molecule was synthesized and subsequently modified that titanium dioxide to produce nanoparticles. The synthesized nanoparticles were applied for the removal of methylene blue and methylene blue commonly considered pollutant. It was determined that the silicon phthalocyanine molecules exhibit high photocatalytic efficiency in degrading methylene blue. Next one, in this study, a nickel metal containing peripherally tetra-substitute phthalocyanine molecule was synthesized, and its potential in solar cells was evaluated. According to the analysis, it was determined that the perovskite solar cell fabricated with the nickel phthalocyanine molecule showed an increasing potential over time and efficiently as data storage and energy storage also. This study was carried out at the Department of Material Engineering at Politecnica della Marca University in Ancona in Italy. We investigated the effect of the original titanium dioxide-based coating material containing peripheral tetra-substitute nickel phthalocyanine, which we synthesized. On the removal of a nitrogen oxide compounds, nitrogen oxide known as major air pollution. As a result, it was determined that the titanium dioxide-based nickel-containing phthalocyanine coating material was 18 times more effective than pure titanium dioxide. Pure titanium dioxide, which is commonly used for nitrogen oxide removal. Following this result, we filed a patent application for the material we developed, and it was granted within a short period of 3 months. We then applied to the Patent Turkey competition at Teknofest. Teknofest, one of the world leading technology competition, and received the 15th place award. In addition, our patent work was awarded a silver medal at the Teknofest 2025 patent fair. Of course, in addition to synthesizing phthalocyanine molecules, we also carried out multidisciplinary studies together with my friend, Associated Professor Dr. Bilge Yilmaz, as she mentioned before. You see here a type pine resin. This is a pine resin. We first convert the resin of rosin, shown here, using the distillation method. Then we esterifying it with various alcohols. We obtain a polymeric material, and which we evaluate for use in various applications. For example, this literature. We product asphalt road marking paint using a material obtained by esterificated rosin with penteritol, which has a high boiling point, and conducted various tests on this paint. The analysis result indicate that the paint we produce is of equivalent of even superior quality compared to paints currently used in our country. Moreover, this achievement was accomplished using a sustainable and environmentally friendly product. And next one, we produced a filter from the esterificated rosin using the electrospinning method and investigated their antibacterial properties. It was determined that the filters we produced exhibit high antibacterial activity. And in this study, I work as a researcher in the project led by Associated Prof. Bilge Yilmaz, which was supported under TÜBİTAK 1520 project in our country. In this work, rosin was esterificated with a valuable alcohol, name is isoamyl alcohol, and the resulting material was evaluated as an alternative to paraffin. Paraffin, you know, chemical product and petrochemical product and cancerogen product used in MDF production. As a result, it was determined that the materials could indeed serve as an environmentally friendly natural alternative to paraffin. Subsequently, we filed a national patent application for this material, Bilge mentioned before. In 2023, at the Technofest Patent Fair, we were awarded the silver medal. Additionally, we received fourth place among 200 projects in the inter-university project market also. The projects I have participated in so far, as well as ongoing projects, are listed here. I am currently the principal investigator of a project supported under TÜBİTAK 1002 project in our country. This project also about my doctoral thesis. In addition, I continue to be involved in projects supported by our university. Here, I am involved as a working group member in several cost actions, and I try to be as active as possible. I am new to this cost activity, LIAISE, and I would like to sincerely thanks the MC members for accept me. I hope this will be a beneficial and productive process both for the action and for me. And this picture is our research group, very crowded. Vasiliki and Natalie and Bilge, all of them. And I hope this presentation has been informative for you. Thank you very much for listening patiently. By the way, if you want to ask questions about my file of work, you can contact me by this email address. Thank you.
Thank you, Hilal. So after that, I'm the host. Yeah, thank you for the presentation. And if
Thank
someone
you.
has a question, so they can contact via the email. Now also the next presentation is for Vasiliki. I think she's co-host now. So Vasiliki, you are here? Yeah.
Yes, thank you so much, Mr. Taner.
Yeah.
Okay, I think that I will try to share my file.
It's coming.
Okay.
Yeah.
First of all, I would like to say hi to everybody. I'm very happy to be here with you today. And thank you so much for the chance that I have to meet you all and introduce myself and have this chance of knowing each other. I have to give my congratulations to the previous presenters. They are very good colleagues, and all these and the previous months, of course, more than 2 years. Now we have also very strong cooperation between Aristotle University of Thessaloniki, which is my affiliation, my university where I work, with KTU. Trabzon Karadeniz University.
Vasiliki, just can you make a presentation mode?
Yes, I have made. It is not.
It's not in presentation mode, but if you are okay for you, then you can continue. It doesn't matter.
For example, now I see it like presentation mode. No.
Yeah, it doesn't matter. So go on.
Okay, okay. Thank you. So my name is Kamperidou Vasiliki, and I work in Aristotle University of Thessaloniki in the School of Forestry and Natural Environment, and specifically in the Laboratory of Forest Products Utilization. So I will make a more generic, okay, it doesn't let me change. So what about now? Does it change?
No, it's in the first.
No. Okay, maybe I have to put it
Now
like
it's
that.
changing.
Okay.
Now it's the second slide.
Sorry about that. Very often it becomes like that. I have to search it. So if you see the change now, I can continue like that. So my university is located in the north part of Greece. It is called Aristotle University of Thessaloniki and is in the city of Thessaloniki. It is one of the biggest of Greece, university of Greece. And it includes 40 different sciences, 40 different departments in this university. I have to say that my department is called Forestry and Natural Environment. It includes 5 years of study, providing also, except for bachelor, also in parallel. In the 5 years, it is also integrated master. Students have also to prepare dissertation and make experimental work in order to combine theoretical work with experimental one. We have also different universities, university forests, where we make the more practical work. And the department where, the sector in the department where I work is the harvesting and forest products technology. So we work mainly in the utilization of forest materials and forest biomass. I have to say that we are a small group, unfortunately. Here I work with Mr. Barboutis. He is a emeritus professor here, who is contributing and helps us with the more practical work. And there are also 3 other members that are professors here. So, for example, for myself, it is easier to work on different subjects in our research field, because I have 3 different PhD candidates, 2 master students, and there are so many people working all around in our labs, but with different subjects. That is what I wanted to conclude, because I will show you some parts of those. We have cooperations through Erasmus students with 25 different countries and universities. That is very good chance also for us, not only the students, to go around and see, try to learn about different laboratories and see the chances to work outside of Greece, to know, to open their minds and build these cooperations. And a few things about our laboratory, specifically my subject officially is chemistry and chemical products of wood. Even though the last years, not the last years, our laboratory has all the equipment and background and knowledge on wood technology. So I tried the last years to combine chemistry with technology fields of wood and biomass. And that is why you will see in the following that we try to cover all the different fields of wood utilization. Okay. Here we can see I tried to include in the presentation different images, providing a bigger image of what is going on and what about the equipment that we usually use here. First of all, the preparation of our wood material, our biomass materials, is very important thing. So we try to cut and prepare to form the samples of us. Every time is different, because we use sometimes solid material, wood materials in specimens, and other times biomass in powder. So we have to prepare first of all our samples, and another very significant topic is the characterization of the material. So every time we start with the raw materials, and we try to form them in suitable dimensions, granulometry, moisture content, and all these density, for example, all these very, very significant properties. And then sometimes it is very significant to see what is going on in the wood structure, the anatomical characteristics of our material. So wood structure is very important most of the times. Here you see again phases of samples formation. in our lab. And here we start with the characterization. Among the properties, of course, most of the times it is significant to see, except for the density, also the mechanical properties of wood. So we see compression, compression strength, also bending strength, elasticity, tensile strength, hardness, all these properties which are very significant most of the times. Of course, most of the times we see how we can improve wood. Another significant research field where I work on with the students as well and the colleagues is the wood preservation and improvement. So we see several different thermal, chemical treatments. I think I have to admit chemical treatments, thermochemical, thermomechanical treatments as well. You see here this image in the center of the bigger sheet, where you see a small press. So we try to heat the materials and let them be impregnated and then to be pressed. So we try different treatments in order to see if we are going to have a stabilized material, which is as well impregnated and thermically treated in order to have it stabilized and improved material. Here you can see that we try also to press and condense our material. For example, if we are talking about biomass material, most of the times we combine wood with other residual biomass materials all together in different ratios in order to see how they react, how they combine and be adhesive, be bonded, the materials. And all this knowledge is very important towards MDF construction, towards pellet construction, different condensed materials. And of course, here you can see other different images of quality control of our samples. For example, here in the top, you can see different materials of plywood that we usually produce, and most of the times we use different adhesives. The last years we try much things, and you can find also publications on our team, on our team's work. They are all published, what I show you in the images. And we try to see what is going on with the biological adhesives. That is why we have also this cooperation with Trabzon on rosin and esterified rosin and all these substances that the previous presenters showed us. Also, the most significant is casein adhesive, rabbit, fish, glues, starch, and rosin, of course. And we try to see how we can treat these substances, these adhesives, in order to behave, to have a better performance. We already know that casein is perform better than the other adhesives, but also now we try to see how casein, for example, adhesive behave when it is together with nanoparticles in order to be, for example, to be employed as a coating material, coating formulation. Since casein also provides fire retardancy. So we make several different tests all these years, and especially they are incorporated also in parallel with different tests. For example, we see different joints, not only finger joint or lap joint. We see corner, as you see also in the images, dowels, mortise and tenon, and different joints. of course, we try to incorporate these natural materials also in particle boards and fiber boards production. Let's say we are a more practical laboratory, and we see how these substances behave in wood-based products. In these images, where we have screws, for example, we have incorporated also casein in the touch, in the connection line between screw and MDF. Here you can see some images from the production, from the viscosity, of course, measurement, and the production of wood-based products, utilizing not only conventional material. Every time we combine conventional adhesives and try to compare them with biological, with natural adhesives, in order to see how they perform. Here in these images, we see the pyrolysis equipment and how we produce biochar in these images here. And also, these are equipment dedicated to the measurement of fire resistance. For example, we see flammability, ignition point, speed of spread of fire on the surface of the wood-based product. And here are some of the smaller, or let's say those that we utilize more often, of the chambers that we treat wood. Smaller, in this case, smaller equipment, and here bigger samples. Of course, there is the possibility, sometimes we apply hydrothermal treatments, chemical treatments, and you have all the possibilities to measure. Some images from the preservation and modification, the natural weathering of the materials, sometimes outside, sometimes artificial weathering inside the chambers, and we try to draw conclusions every time. You can see also in ResearchGate, trying to find my name, also you will find the results of us, of these different publications. A few images from the chemistry lab in our department, in our section of department, and trying to isolate, of course, and characterize the material chemically. So we see lignin, we isolate cellulose and hemicelluloses. We try to see what is going on with these extractives to be characterized with NMR and other analytical methods. Some images from the students' work of the current years on rosin, on the production of different composite materials, insulating materials from bark. Bark is a very, very significant residual material of forest, and we try to incorporate in several different fields. For example, one of the applications is pellets that we see here, as well as the incorporation in cement and lime matrix in order to improve the properties of the composites for building, for example, materials. Also, one of the images towards this direction. And also here, what I described you on lime and cement, we try to improve the cohesion and the post-cracking resistance. So after we incorporate bark or wood or other biological materials in order to reduce post-cracking resistance, to increase the resistance, and of course to make them more plasticized. Okay, just only a few images more, and of course one of the most important. Okay, also here you see different steps of gluing and the formation of the samples of us, and we try all these biological adhesives to be tested not only in plywood, which was one of the most recent cooperation with Mrs. Yilmaz, the colleague that is among us, but also in glulam that you see also in the corner. Okay, that's all for me for today. I remain at your disposal for any question. Of course, you can find me also in this mail. And this is the link of our laboratory for more information and to know us better if you believe that we can cooperate somehow. If there is any interest of contacting us and work together, that would be a great opportunity. Thank you very much for your time and attention.
Thank you, Vasiliki, for the presentation. It's very nice. And I want to mention also the 2 years ago, I was in the Thessaloniki to visit your university. So
Ah,
yeah, I
okay.
worked for 1 month there. So.
In which department?
Chemistry, especially in food
Chemistry.
chemistry.
Oh, we have a very close cooperation with chemistry, of course.
Yeah, it's
But
so big university, yeah.
At that time, probably I was not here. Was it 2020?
No, it's 2 years ago.
2 years ago.
Yeah.
Oh, so bad I didn't meet you in person. But next time.
Yeah, exactly.
We have to work together.
Yeah.
Okay.
Yeah, exactly. So thank you so much for presentation, and thank you to Bilge, Hilal, and Vasiliki. I think we can finalize today's forum. So if anyone has a question, so you can contact with the through the emails or through us, and we can contact you also again. So thank you so much. Keep in touch.
Thank you as well.
I take
Bye-bye.
photo.
Bye-bye.
By the way.
Have a
Thank
nice
you.
day.
Have a nice day, Vasiliki, Taner. Bye bye.
Bye-bye.
Bye.